All right, hello everyone, and welcome to our final day looking at graphing complex rational functions. All right, so we'll do a quick review slash summary, and then we will get right into our lesson here, okay? Because I want to make sure we get through at least two graphs. All right, so our final day here. Let's take a look at these things. So we started with talking the way I would ask you, to start kind of graphing rational functions, these more complex ones, is to start with your domain and your domain restrictions, right? That's looking at the denominator of your rational function, setting that denominator equal to 0, and then seeing when your denominator is 0. Okay. Once you have those domain restrictions, they're going to further classify. So you will further identify those domain restrictions as either vertical asymptotes or holes, okay? There's no third mystery category. They will either be a vertical asymptote or a hole. You will know you have a vertical asymptote if that x value makes you divide by 0, okay? So it gives you a 0 in the denominator, but it does not give you a 0 in the numerator. That's why I leave this little thing here blank, okay? On the other hand, a hole, if you imagine plugging that restricted x value in, you would get 0 in the numerator and the denominator. Okay, and that kind of is, pairs with the idea that the whole, you can kind of cancel out something from the numerator and denominator, right? That factor that gives you that excluded x value in the denominator is also, that factor also exists in the numerator, which allows you to further cancel it out. So that's why it creates 0 over 0 in the numerator and denominator for a whole. Okay, so that's the major differences there. Okay, next we're going to identify any horizontal asymptotes or slant asymptotes, okay? So vertical asymptotes and holes are mutually exclusive. You should never get an x value that it has both a vertical asymptote and a hole at the same x value. Should never happen. Likewise, a graph will never have, well, none of our graphs here will have a vertical asymptote and a slant asymptote. They will be mutually exclusive of one another, okay? So that was what we talked about yesterday, this stuff right here, okay? So when your degree of the numerator is bigger than, if the degree of the numerator is smaller than the degree of the denominator, then you have a horizontal asymptote at y equals 0. If the degree of the numerator is equal to the degree of the denominator, that's where your horizontal asymptote is at y equals the ratio of the lead coefficients. Okay, and then finally, if the numerator's degree is bigger than the denominator's degree, there is no horizontal asymptote. But if the degree of the numerator, if the numerator degree is 1 more than the denominator degree, then an SA exists. Okay, a slant asymptote exists. How do you find a slant asymptote? You find it by dividing the numerator by the denominator and throwing out the remainder. Okay, and then you graph that linear equation that you'll end up with. Okay, so throw out the denominator. Throw out the remainder, that remaining, piece, the other piece, the original piece for the answer to the division problem, that will be a linear equation. You graph that like you would any other. It's in slope-intercept form, and I'll show you one here today as an example. Then you find your zeros. Again, these are just some points to help you kind of figure out the graph. You set the numerator equal to 0 only. I mean, truly, whenever you want to find a 0 or x-intercept, you set your function equal to 0, right? But that is when, just in the rational function, it's just when the numerator equals 0. If you want to find the y-intercept, we haven't really done that, but if you want to, you just plug 0 in for x and then solve, okay? And then number 6, you graph everything. Make sure you start with graphing the asymptotes and the zeros, right? And then make a table if necessary. I would encourage you to have at least 1 point on each side of a vertical asymptote. So if you have one vertical asymptote, try and pick a point to the right of it, to the left of it, okay? And then plug those in and get the matching y values to help you figure out what your graph's going to look like. And then use the asymptotes to guide you. And then finally, identify the range once you got the graph down. Okay, another thing I want to mention here, sorry, I skipped over number 3. I didn't mention this. The horizontal asymptotes and slant asymptotes, those are essentially like end behavior. That's us finding the end behavior there. Okay, all right, anyway, let's take a look at this graph. So here's our function, right? It's x squared plus x minus 2 over x plus 3. This, I'm going to go ahead and factor it, even though, our first question there is just to find the domain. We don't need to factor it to find the domain, but it'll be helpful just for the future here. Okay, so there's our function factored. The domain, when will this thing, what x values will cause us problems? Well, it's when x is negative 3, right? If it's when that x plus 3 equals 0, okay? So we'll just go ahead and write our domain out. Negative infinity to negative 3, union negative 3 to infinity. There's only one number to remove from our interval there. All right, if you're having trouble with this interval notation, just remember, think about, we're in a number line here. We're going to start at negative infinity and go up to that negative 3. And they're going, negative infinity up to that negative 3, where the problem is we exclude that negative 3, that's the parenthesis, and then we start back at negative 3, excluding it, but then we go to positive infinity there. Okay, all right, so then what do we have, a vertical asymptote or hole? So this x equals -3 that we're excluding, right, that's either going to be a vertical asymptote or a hole. Looking at our factored function here, right, if I plug -3 into the denominator, we get 0 in the denominator, right? But if we plug -3 into the numerator, I will not get 0, okay? This does not make 0, this does not make 0, and so I won't get 0. And so it's going to be a vertical asymptote at x equals -3, because I don't get 0 over 0, I just get some other number that's not 0 over 0. Okay? For horizontal slant asymptote, we're going to go to our rules here. The degree of the numerator is 2, the degree of the denominator is 1, so there is no horizontal asymptote because the numerator's degree is greater than the denominator's. However, since the numerator's degree is 1 more, we can find a slant asymptote here. So here's your promised problem. So we're going to go ahead and do the division. I'll just squeeze it in right here. Okay, I won't talk through it too much here, just because we've seen this already. Okay, just subtract, add the opposite, so that cancels. You get -2x minus 2, and then we'll put a -2. -2 times -x minus 2x minus 6, and then again subtract. But instead of subtracting, I'll add the opposites here. Again, that's a 6, and then those cancel. And -2 and 6 is 4. Again, throw out the remainder. That's the equation for our slant asymptote. So SA at y equals x minus 2. It's just in slope-intercept form, right? So just graph it in slope-intercept form. In fact, I'll go ahead and put them in right now. So vertical asymptote -3, like that. Slant asymptote at x minus 2. So here's -2. That's our y-intercept. And again, I drew that dot. Maybe I shouldn't have it. But, you can kind of like, okay, there. Slopes up 1, right 1, up 1, oof, right 1. So it's going to look something like this. Okay, like that. And that's our slant asymptote, okay? Zeros, so again, we'll just set the numerator equal to 0, so that's at x plus 2 equals 0 and x minus 1 equals 0. Again, this thing overall only equals 0 when the numerator is 0. The numerator will equal 0 when x plus 2 is 0 or x minus 1 is 0, so you get x equals -2 and x equals 1. And so we'll plug those, or we can plot those here too. So there's -2, there's 1, and you can kind of already get an idea about what the graph's going to look like. It's going to look something like this. Okay, something like that, where it's going to approach those asymptotes. We do get some graph down here. It's going to be hard to see, though, because of the scale that I used, I think. But let me go ahead and just go ahead and pick a point. So I'll go ahead and use this point right here, which is -4. And I'll plug in -4 here. So let's see here. Wait, if I, do an x, a little chart here. So -4. If I plug that in, it's going to be, let's see here, -4 plus 2 is -2, -4 minus 1 is -5, and -4 plus 3 is -1. Okay, so that's going to be -10, or sorry, 10 divided by -1, so it's -10. Okay, so you can see that's not going to quite fit, but it would be like down, I don't know, like down here or something like that, and so your graph would look, something like this. Okay, but again, I can't quite fit that in. So what's the range? Ooh, the range here is going to be kind of tricky, actually. So in this case, we don't know how to find this max and min without using our graphing calculators. So I'd just say use your graphing calculators. Find the minimum of this value, find the maximum of this value. Okay. I don't think I will have you find a range for this kind of problem. So you can also just forget it if you want to. Okay. I'll get you guys the answer for that here at the end if you are curious about what the range really is, though. So let's just go ahead and move on to the next problem, though, while we're doing that. Okay. All right, so next here. All right, here's another function we've got. All right, you can see here I got some factoring to do as well. I'm going to erase this from the previous problem here. Let's put it like up here like that. Okay. So let's factor this thing here. So if you look at that denominator, right, there's a GCF in there. So we'll factor out an x, and that leaves behind x squared minus 2x minus 3, okay, which further factors in that quadratic form to be x minus 3, x plus 1, okay? And so we can now talk about our domain, okay? What are the domain values that will be restricted here from this? Well, again, you can set x equals 0, you can set x minus 3 equal to 0, you can set x plus 1 equals 0, and so we'll get x cannot equal 3, right? And x cannot be -1. Okay, so what's our domain going to be? Well, so -infinity, comma, what's the first domain restriction we come to in numeric order. The first one we'll hit is that -1, okay? So we'll go from -infinity to -1, union, we'll start back at the -1. What's the next domain restriction we get to is 0, and then we'll start back at the 0, and we'll go to the 3, and then we'll go from the 3 to infinity. Okay, so you have to like break up all those intervals over the number line there, okay? All right, so then let's continue on and identify. So all these numbers, the 0, the 3, the -1, these all have to identify as either vertical asymptotes or slant asymptotes. Okay, so let's identify these. So again, you can kind of see here that x does not cancel with anything in the numerator, so it's going to be a vertical asymptote at 0. Okay, and then we will further have a vertical asymptote at x minus 3 because there's nothing in the numerator that it will cancel with, so also x equals 3. And then we have a hole, a hole at x equals -1. And the reason for that is because those x plus 1s will cancel. In fact, if we go ahead and kind of like cancel those, then this will become 1 over x times x minus 3. Okay, and we can find the x coordinate for our hole by plugging that x equals -1 into this simplified version of the function. So I'll go ahead and plug in -1. Okay, and so we get 1 over, let's see here, -1 minus 3 is -4 times -1 is 4. So we just get positive 1/4. So in other words, -1 1/4 is a hole. Okay, and you can go ahead and plot that too if you want to on the graph over here. Okay, I didn't leave myself very much space, but we can, let me see if I can like grab this without going to, oh, of course it's not gonna. Try this again here, let me just lasso this. Okay, that'll work. So anyway, let's zoom back in some here. So I'll go ahead and plot that hole at -1 1/4, so -1 1/4, it's gonna look something, you know, like that. So you actually draw an open circle there for the hole. A vertical asymptote at 0, so that's our x, or I mean our y axis here, and I didn't do a very good job. Oh shoot. Okay. All along the axis there. Okay, and then at 3. Okay. We got to find our horizontal asymptote / slant asymptote, and the good news is since the numerator's degree is just a 1, the denominator's degree is 3, and so that means the numerator's degree is smaller than the denominator's degree, which we have a horizontal asymptote at y equals 0. So on the x-axis we also have a horizontal asymptote. Okay. Zeros, so this is only going to equal 0 when the numerator equals 0, so we set x plus 1 equal to 0, so that would indicate that x equals -1. However, remember, -1 is excluded from our domain, so there are no zeros. This thing does not have a 0 that crosses the x-axis. Okay, and then for our range, well, we'll talk about that here in just a second too. Okay, so let's get this thing graphed. So let's see here. I don't have any other points to put down, so I got to just plug in some stuff here. So I'll plug in like let's see here, I'll make a little chart. Okay, and I'll plug in. So I already have a point like right here, so I know that my graph's going to kind of come down like this, hit that hole, and then kind of, oof, that was, the second one was not as good. Kind of go out like that. Okay, should be more like round down here, but you know, I didn't do a very good job. But you get the idea. Okay, let's go ahead and pick a nice point over here. So let's do pick like 4. Okay, so I'll plug in 4. All right, so then 4, we've got, if I plug that in, we'll get 1/4 as well. So 4 1/4, just like right there. And so our graph's going to come down and look like this. Okay, and then let's pick like, I'll do 1 and 2 here, just to kind of like give us some nice, you know, give us nice 2 points there. Again, this x coordinate 1, this x coordinate 2. So let's see, if I plug in 1, I will get -1/2, I think. 1 times 1 minus 3. Yep. And if I plug in 2, I'll get also -1/2, I think. 2 minus 3 is -1 times 2. Yep, -1/2. Okay, so 1 -1/2, 2 -1/2, and so it's going to look something like this. Okay, and so there's our graph. All right, I will give you guys your assignment on Schoology. Again, I'm only going to give like 2 of these probably. All right, so yeah, tomorrow will be a quiz. All right, and you may use your notes on that quiz tomorrow, and you know, any of these, any of the homeworks and stuff like that too. So thanks, guys. Have a good day.